We're starting section 3.7, the chain rule. First, we talk about the composition of functions, and then we give you the chain rule. What is chain rule? Chain rule is just the rule, the derivative rule that helps us take the derivative of composition of functions. And this is where you're prepared for doing your derivative exams, basically. Example 1. There's this story. Albert is being rescued on top of the mountains, and a chopper is out there and trying to figure out what time they should come down to basically drop the ladder and get Albert. Albert is running fast because there are wild animals down here in the island where the mountain is, and he's going straight up. What he does is, as he climbs the mountain, he also travels horizontally on some, and then travels some vertically. X is the horizontal distance that he travels, and H is the vertical distance with respect to the horizontal distance that he is traveling. Basically, it tells you about the slope of the mountain a little bit. And so he is, true, he knows his speed of climbing, and he knows where he is, but he can't communicate with the pilot. Pilot looks down, and he sees, basically, he's a flat earther. He sees just above perspective of the entire story. So he only sees how fast Albert is traveling horizontally, but he's just interested in knowing how fast Albert is traveling vertically, because he's interested in, do you see the dashed line? He's interested in time that Albert gets to that dashed line where he actually should go down and drop the ladder, because it's safe for the chopper to come down and actually get Albert at that level. Otherwise, it's the mountain, it's dangerous for the chopper. So that's the basic of the story. And so Albert is running, and Chopper is looking. Chopper knows how fast the pilot knows how fast he's running horizontally, but he also knows the slope of the mountains and of this mountain, and that helps him figure out how fast Albert is running up, basically. And so this story, now we want to talk about an iClicker question from this story. So iClicker question 1. In Albert's example, what is the physical interpretation of dh dx, derivative of h with respect to x, which, remember, h was the vertical distance, x was the horizontal distance, and dx dt, which x is again horizontal distance and t is time. So we want to figure out what's the physical interpretation of dh dx and dx dt, or derivative of vertical distance over derivative with respect to horizontal distance, and derivative of horizontal distance with respect to time. And so again, the derivative of the vertical distance with respect to horizontal distance is just the slope of the hill. The derivative of the horizontal distance with respect to time is going to be the horizontal velocity. So B is the answer. Let's review composition of functions. If f and g are functions, their composition f of g and g of f are f of g of x is f of g of x, as is read. So it's f of g of x is f of g of x. That's the input of f. G of x will be the input of f. And g of f of x is going to be g of input f of x. So now let's do one example to remember how it works. Let's have f of u equal to square root of u and g of x to be 1 over x minus 3. F of g of x is going to be basically, what is the outside function? F. What is the inside function? G. So what I do is I write the outside function and put a big parentheses for the inside function, for the input variable. Then I plug in the inside function. Everywhere I see the parentheses for input variable. How about now, and that would be square root of 1 over x minus 3, sorry. How about now how about g of f of u? Now, outside function is 1 over big parentheses, instead of the input variable, minus 3. 1 over x minus 3 becomes 1 over big parentheses minus 3. Now plug in the inside function, which is f in here, square root of u, and you get 1 over square root of u minus 3. So then again, composition is basically you think about what's inside and what is outside, and when you're calculating, you basically figuring out the inside first and then you're plugging it into the outside. And in this section we are going to talk about the innermost, and then the next level, the next level, and the next level, because composition of function can happen in many layers. Basically, it could be, function can be composition of 2, 3, 4 functions or more. So when we're talking about the inner function, something in this case is you start from innermost function. That's the one that would be actually, that would take the input variable basically. The input variable, for example, in here takes the x, g takes the x, and then f takes the g, output of g basically. And so now looking at, for example, these examples, over here, the innermost is h, and h, basically h is the one that acts on x, then g is the one that acts over the output of h, and f is the one that acts on output of g. And then f of g of h of f of g of h of k of x is f of g of h of k of x basically. And so again, k is the one that takes x in as input and gives the output of k is going to be. I click here question 2. You own a company that produces ice squids, the latest electronic grades. Your big production limitation is scarcity of chip 187 produced by outside manufacturers. If f of x is the profit you will make if you can get x chip 187s, and g of x is the number of chip 187s, you can obtain for X dollars. The number of chip you can obtain from X dollars. Which of the following is of interest to you? A, f of g, B, g of f, C, both, D, neither. So let's think about this and come up with a solution. So the story is when you're basically g of x will give you the number of chip you can obtain when you have X dollars. And you have X dollars, you want to make this X dollars to a better profit out there. And so you basically, you want to see if I input X dollars, how many chip I get, then that many chip, how much profit does it make for me in terms of dollars? So the very input is X as your money, and that's G, and then G, then F. So F or G is the one that you're interested in. That is option